For over a century, we've defined robots by the cold materials that make them: silicon, steel, copper, and plastic. We built them to be strong, but rigid. We built them to be smart, but fragile. If you drop a phone, it breaks. If a copper wire snaps, the machine dies. But nature has a different rulebook. Nature builds machines that are soft, self-healing, completely biodegradable, and capable of reprogramming themselves on the fly. And now, scientists have just bridged the gap. They have successfully built the world's first living robots. Built not from metal, but from biological cells. And the wildest part? They are now making them from human cells. These are no longer just passive blobs of tissue. They are programmable biological agents that can swim, swarm, navigate our bodies, and even heal damaged human neurons on command. Welcome to Mind and Marvel, where science, survival, and the superhuman collide. Today, we are breaking down the Xenobot revolution and how scientists have unlocked the hidden software inside our own cells to build a brand new form of life. Our story begins at the University of Vermont and Tufts University. Researchers wanted to answer a fundamental question: if you take cells away from their normal home in an embryo, can they figure out how to build a completely new body plan? To do this, they didn't ask a human engineer. They asked an artificial intelligence. They gave the AI a virtual sandbox, a set of physical rules, and two biological building blocks: frog skin cells for structure, and frog heart cells to act as tiny motors. Think of how we normally build machines. It's like playing with Lego bricks. You have rigid, fixed pieces that can only connect in certain ways, and you need to supply an external battery. But biological cells are like smart, living Play-Doh. They can communicate, self-assemble, and they already come with their own internal fuel source. The AI went through millions of evolutionary designs until it found the perfect shape for locomotion. The scientists then manually sculpted living frog stem cells to match the AI's blueprint. The result? The Xenobot. A living, programmable organism less than a millimeter wide that could walk, swim, clear debris, and even heal itself when cut completely in half. But frog cells can only take us so far. Our immune systems would instantly reject them if we tried to use them inside our bodies. So the researchers posed an even bolder question: can we build these biological machines using adult human cells? They turned to the human trachea, specifically the airway epithelial cells. In your throat, these cells have a very quiet, stationary job. They are covered in tiny, hair-like projections called cilia that wave back and forth like microscopic brooms to sweep dust and mucus out of your lungs. They are the body's internal cleaning crew. But the scientists decided to give these cells a biological reboot. They took them out of the lungs and grew them in a liquid medium without any rigid scaffolding to hold them in place. Left to their own devices, the cells did something spectacular. They self-assembled. They folded themselves inside out, placing their tiny cilia on the outside of their bodies. Suddenly, those stationary brooms became oars. The cells had constructed themselves into mobile, biological vehicles. The scientists named them Anthrobots, and they did all of this with zero genetic modification. They simply read the hidden, secondary software program already written into human DNA. So, what can a swarm of human lung cell robots actually do? To test their therapeutic superpower, scientists set up a high-stakes obstacle course. They grew a flat layer of living human neurons in a dish and scratched a deep wound right through the center, severing the connections. In normal conditions, these neurons cannot bridge the gap. The damage is permanent. But then, they introduced the Anthrobots. When confined to the scratch, the individual bots naturally huddled together to form a superbot. Without any external guidance, the Anthrobot bridge triggered massive neural regeneration. Within days, a thick bridge of healthy firing neurons grew across the gap, completely healing the wound. The neurons did not grow where the Anthrobots were absent. Somehow, these unmodified biological machines are sending cellular instruction signals that tell our nerves how to repair themselves. What makes these biobots so revolutionary is their life cycles. Traditional robots require constant maintenance, fossil fuels, or heavy batteries, but Anthrobots run on basic cellular nutrients. They are 100% biodegradable. After about 45 to 60 days, their mission is complete. They simply stop moving, dissolve naturally, and are absorbed by the body. No toxic microplastics, no lithium batteries, no permanent artificial footprint. And in the case of Xenobots, they've even demonstrated kinetic self-replication. If you place them in a dish with loose stem cells, they will work together like a herd of sheepdogs, corralling the cells into a pile. Over a few days, that pile self-assembles into a brand new, functioning baby biobot. They are machines that can literally assemble their own successors. We are standing at the absolute dawn of personalized, living medicine. Because Anthrobots are made from a patient's own cells, there is zero risk of immune rejection. In the near future, doctors could harvest your own lung cells, use AI to design custom biobots, and inject a personalized swarm into your bloodstream. They could clear arterial plaque, hunt down and destroy cancer cells in the deep brain, or deliver target chemotherapy with molecular precision. The boundary between the born and the made is gone. This is the ultimate synergy of life and machine. This is where science, survival, and the superhuman collide. We spent centuries trying to conquer nature with steel and concrete. It turns out, the ultimate machine was already inside of us, waiting to be awakened. Because at the end of the day, biology isn't just a state of being, it's code. And we finally have the keys to write the program. So next time you think of a robot, don't think of silicon, steel, and copper.